Millions of people worldwide lack access to electricity, leading them to use firewood or charcoal indoors to satisfy their basic needs of cooking and heating. However, this causes poor indoor air quality and can lead to serious health issues over time. It can also contribute to deforestation in surrounding areas, as trees will constantly need to be harvested for fuel. Our project explores the idea of using biomass briquettes as an alternative fuel source which burn cleaner and more consistently. These briquettes are created from using waste biomass material such as sawdust or small wood shreds, which would otherwise be put to no good use. To address our problem, we developed a biomass briquetter that can efficiently and effectively compress sawdust into strong briquettes that are both transportable fuel sources and sustainable for various applications, such as cooking and heating.
Hi everyone, so the first step, this right here is an intake of the air compressor. It goes into a solenoid valve, which controls when our bottle jack will be on or off. This box right here, we have a moving and an emergency stop light to indicate the status of our machine, and then this button right here will start. Emergency stop button will stop the process at any point in time, and then we can quickly reset it to continue to make briquettes. Looking at this system here, we have bungee cords which help retract the plunger after it reaches its maximum extension. Looking out a little bit more, this right here is the hopper where the biomass is fed into. It is pushed from the plunger inside this pipe and then is extruded out the end here. Right here, we have a band heater that's heated to 350 degrees Fahrenheit. This is our servo motor, which is a set of 2 gears which controls the opening and closing of our release valve. At any point in the process, you can hit the emergency stop button to stop the process and then retract the plunger. The plunger retracts, and indicated by the light, is now ready to be restarted.
So here's just a closer look at some of the briquettes we've produced. You can see on the outside of these we have this nice glossy finish. That's due to the lignin and the wood fibers that is melting and then adhering on the outside to keep this all together as a nice puck. As we can see here, they're quite solid, burn very well, and are a nice finished product that you can take camping, backpacking, whatever your needs are to burn later on.
Future improvements include a better hopper feeder system to pack more sawdust in to get more output, and then a catch to catch the briquetters once they fall off.
This is an overview of the briquetter box. From the outside, we've got a few various wires. This one goes to the heater. This guy plugs in for our wall power, AC power, and this one plugs in to the wall to convert AC to DC for the Arduino and other DC components. These wires go to the servo, and finally we've got the thermocouple. The top of the box, we've got some pretty basic controls. There's an emergency stop button. There's the go button, which turns on the briquetter. Essentially, we've got power coming in, going to the main rail right here. This power distribution block just provides power to this solid state relay and this mechanical relay. The mechanical relay powers the solenoid up here. This solid state relay turns on and off the heater. We chose a solid state relay because a solid state relay allows us to switch it on and off at a higher rate than a mechanical relay. These are our LEDs. They're hooked up just with some resistors in there to keep them from blowing up. The entire breadboard is wired up to the 7.5 volts at 3 amps. And then we've got an Arduino with all the pins hooked up to go to various places. The Arduino switches on both the solid state relay and the mechanical relay, and then also controls the LEDs directly.
A high-level overview of our code is that after we include all of our libraries and define all our pins, we have a big switch case statement that essentially gets ran multiple times in a second. At the start of the loop, we just check if the e-stop button's been pressed. If the e-stop button's been pressed, we go into the e-stop state. Normal operation, we are either in the ready state, which is when the green LED's on, the extending state, which is when the solenoid is open, or in the retracting state, which is when the servo is open and retracting plunger. We also have the heater function, which essentially just checks if the heater is above the set point. If it's above the set point, it will turn the heater off, and if it's below the set point, it'll turn the heater on.
We're going.
Hi everyone, this is our MEGN301. Okay. Oh wait, I got it. Shut up.
It's quiet.
So, okay,
Start it over.
Okay. Alright.
Dog, you are the worst. Are you? Okay.